All right, today we're going to do day one of polar equations. So we're going to start introducing you to what a polar equation looks like and how to plot it on a graph. We're going to start by reviewing what we know. So this right here is the rectangular or Cartesian coordinates. This is the one that you're accustomed to because you've been working with for a while. The point in the center here for the Cartesian is called the origin at point 0, 0. This part right here would be the positive x-axis. And when we write ordered pairs, we write them as x, comma, y. On the right here, you see the polar grid, and we use polar coordinates to write this. Polar coordinates are r, comma, theta, the angle. This point in the center right here is called the pole. So this is our pole right here for the polar grid. And then this side right here, that positive x-axis is called the polar axis. So there's no y-axis. We said the point is r, comma, theta. Well, r is the radial distance, which means outward from the pole. When we count that out, that means this would be 1, 2, 3, 4, 5, 6, 7, 8. This goes up to 8. You start from the pole and you're counting out. That's that R value. The theta is the angle from the polar axis. And it is measured counterclockwise. That's similar to the unit circle that we talked about previously. So 0 is right here, and then we measure all the way around. You're going to run into several different polar coordinates, so we really divide, and we'll show you that in 1 second. But these are all angles. So the angle would be from that polar axis to that turn. For example, this one right here, which is the 90 degrees, would be all the way around to 90 degrees. The one in the middle here would be our 45 degrees. So from this polar axis to that point would be 45 degrees. That's what would go in our theta. So it is r, comma, theta, theta being the axis, r being the distance that it goes out from that pole. So let's look at some examples of what that looks like when we work problems. All right, so before we get started on plotting a point for this, I want to go through and show you what that means. So between our 0 here and our pi, which we know is right here, there is 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12 on this particular polar grid. So you do have to look at that when you look at the polar grid. Some of them have more angles drawn than others. This particular one has 12. That means that this one would be pi over 12. The next one would be 2 pi over 12, which does reduce to pi over 6. The next one would be 3 pi over 12, which would reduce to pi over 4. The next one would be 4 pi over 12, which reduces to pi over 3. The next one would be our 5 pi over 12. That does not reduce. And then the next one would be 6 pi over 12, which is pi over 2. And you would continue that all the way around. This would be 7 pi over 12, 8 pi over 12, 9 pi, and so on. This being 12 pi over 12, which is just pi. And then you would keep going again. This would end up reducing to 3 pi over 2. That was our 0. So those are the ones that are really important that you recognize as pi over 2, pi, 3 pi over 2, and 0. And of course, the ones from the unit circle you should know, which is that pi over 4, pi over 6, and pi over 3. Now, to plot this point, 4 pi over 4, since we already have that one, that's this angle right here. So we would need this line, and then we want to go 4 because that's the r. This is the r, and this is the theta. So I use my theta to come up with a line here. And then I used my 4 to plot it. So 1, 2, 3, and 4. That would be my point right there on the polar grid. Now, if you want to go ahead and pause and plot the next example there so you can check your work, you can do that as we move forward on this. All right, so our next point, 3, 0. Well, 0 degrees is right here. And we're going to go 3. So 1, 2, and 3. And so that would be my A point. For B, I need 5 pi over 3. And so 5 pi over 3 is going to come over here to this one here. And we want to go 4 units on that one. So 1, 2, 3, and 4. Our next one here is -5 and pi over 4. We know that pi over 4 is this middle angle, so this one right here is pi over 4. Now we want -5. 5 would be in this direction, but I need -5, so that's going to come out in this direction. So I would go 1, 2, 3, 4, and 5, and that would be our C point. Our D is 6 and -pi over 4, so our angle here is negative. Our angles go counterclockwise this way, so if we were going negative, it would come out this way. And so -pi over 4 is that center one here. This would be -pi over 4. And we want to go out 6 on that one. So 1, 2, 3, 4, 5, and 6. And there is our D. I think I went one too far on that B, now that I'm seeing that. That was 4. And so there's our 4 points plotted. You need to get comfortable using that coordinate grid, just like you got comfortable using the Cartesian grid. So again, this is R, this is theta. So you're going to find the theta, which line it is, and then you count from the pole out for the R. This next thing we're going to look at is converting from the polar coordinates to the rectangular coordinates. And so we're going to have to use some of the stuff that we have learned in the past now, just so that you see where this is coming from. It says use the diagram to the right to find an expression for cosine and sine. And so if this point right here is x, y, we know that this has to be a distance of x, and this has to be a distance of y. Since it is coming from 0 to this point, that would be our distance x, and then that would be our distance y. Now we know cosine is our adjacent over our hypotenuse. So the adjacent angle here to the angle is x. So we get x over our hypotenuse, which is r. And for sine of theta, it is the opposite over the hypotenuse. And so that is y over r. We're going to use those to really think through what these points look like. So if I was trying to get the x by itself here, I would cross multiply or multiply both sides times this r. So x then has to be equal to r times the cosine of theta. For the sine, I would multiply both sides times r. So y is equal to sine of theta. Those are the two that we would use in order to convert from polar coordinates to rectangular coordinates. We're also going to use those to convert from rectangular equations to polar ones and back and forth. As we're talking about those, we should also remember that in our trig unit, we learned that cosine squared of theta times sine squared of theta was equal to 1. That means that x over r squared plus y over r squared equals 1. And if I simplify that further, that would be x squared over r squared plus y squared over r squared is 1. And I can multiply this whole equation times r squared. So another good one to know is x squared plus y squared equals r squared. So we've got r is equal to x equals r times cosine of theta, y is equal to r times sine of theta, and x squared plus y squared is r squared. All right, so let's use that to convert. It says convert from polar to rectangular coordinates. So here is my polar coordinate. Again, that is r, comma, theta. And so we are going to convert that. To come up with the x, we do r cosine of theta. And to come up with the y, we do r sine of theta. So we are going to have to do both of those there. So I get x equals 4 cosine of pi over 3. And y is equal to 4 times the sine of pi over 3. You got to go back and think about that unit circle now. And so the cosine of pi over 3 on the unit circle is 1/2. And so 4 times 1/2 is 2. In this case, the sine of pi over 3 is the square root of 3 over 2. And so this 2 would reduce this to 2. And so we get y is equal to 2 root 3. And so our ordered pair is 2, 2 root 3. Let's try another one. X is equal to our r times our cosine of negative pi over 6. And y is equal to -2 times sine of negative pi over 6. We go back to that unit circle and we think about that. Negative pi over 6 goes in the clockwise position. So that's going to be the same thing as 11 pi over 6. And so we get the cosine one is root 3 over 2. And so that 2 cancels that one. So we get x is equal to negative root 3. And then over here, we're going to multiply times the sine of negative pi over 6, which is negative 1/2. And so that becomes a positive 1. And so our ordered pair there is negative root 3 and 1. So we changed it from the polar coordinate to its matching rectangular coordinate. Now on this next one, we're going to go the other way. And these, you got to put a little more thought to it, but it works the same way. We want to take this from its x, y to the r theta. All right, so let's think about that. We just learned that x squared plus y squared equals r squared. So that's going to allow us to find the r. That's the easier part. So I square 0 and I square 3, and that is going to be equal to r squared. I'm using this right here, x squared plus y squared equals r squared. So I've squared my x term, I've squared my y term to get that. And so we get 9 is equal to r squared. And so 3 is equal to r. So now I've got this first part, but I still need to find the angle. And this one's kind of a special case. So let's think about what that looks like graphed on the regular Cartesian. 0, 3 would be that point right there. So if I did this in its proper way of finding the angle, we would discover it's undefined, and that's because it's this one right here. You should know that that is pi over 2. So theta is equal to pi over 2, and so we get 3 pi over 2. And we'll come back to show you what that looks like when you're getting it in the correct form. Let's try another one. So here we get 2 squared plus -2 squared is equal to r squared. 2 squared is 4, -2 squared is 4. And so we get 8 is equal to r squared. We take the square root of both sides and we get the square root of 8. Now this can be simplified. Remember, your biggest perfect square that goes into that is 4. And so the square root of 4 is 2, and 4 times 2 is 8. And so that would be our simplified radical form. Now, to find that angle, if we go back and think about that angle, let's go back to our diagram here. To find this angle, we would use our tangent, which is opposite over adjacent. So it is y over x. So the tangent of theta would be y over x, which we have because these are our x and y values. So for the tangent of theta, we would get -2 over 2. So we're looking for the tangent of theta that's equal to -1. This is using that unit circle backwards now. So you've got to think about, where is the tangent of theta -1? Well, we know in order for the y and the x to be -1, they have to be the same number. And so the only one on the unit circle that gives us the same number is that root 2 over 2. and root 2 over 2. Now, one of them has to be negative. So we know that it has to be in the second or the fourth quadrant. And so if we think about this point right here, 2, -2, that point's in the fourth quadrant. So we need the one in the fourth quadrant, which is 7 pi over 4. That is the angle that would give me a tangent value of -1. And so our ordered pair here would be 2 root 2. And then 7 pi over 4. Now, let's go back to this one just to remind you of that. So tangent of theta would be our y over our x. And that's why I said this one was a special case, because remember, we cannot divide by 0. That is undefined. So we're looking for where the tangent value is undefined or our x value is 0. And so we knew that was pi over 2 there. All right, let's try another one. We get negative root 3 squared plus 1 squared is equal to r squared. And so that gives us 3 plus 1 is equal to r squared. So 4 is r squared. So 2 is r when we take the square root of both sides. So now we've got our r value. Now we need to find our angle. So we do the tangent of theta is equal to our y value over our x value. Now remember, when we were doing our sine, cosine, and tangent, we knew that we had to rationalize this. So we multiply both the numerator and the denominator by the square root of 3. So that gives us negative root 3 over 3. So we need to go back and think about what angle gives us this from the unit circle. And so we know the value that gives us this negative root 3 over 3 is going to be our 5 pi over 6. Or our 11 pi over 6. So we think about where this point is. And so the negative square root of 3 goes here and 1 goes here. So that's where our ordered pair is, in the second quadrant. And so we need the one that's in the second quadrant. So that's 5 pi over 6. And so we get 2, 5 pi over 6. So you should be able to graph the polar coordinates. You should be able to convert them to rectangular coordinates, and you should be able to convert the polar coordinates to the rectangular to polar, both ways.